Hello everyone, I'm Shunya Seiya. Today I'd like to talk about CARLA challenge. This is a CARLA challenge homepage, and this is about results of CARLA challenge in this year. So the CARLA team provide 4 tracks, and yeah, here is my result. I participate in track 3. That is talk after. And my result is second, and the point is 66 points, and 0.5. That is have different 6 points from third result, and that is a close result of me. 0.8. Yeah, that's a little bit sad. Yeah, but today I talk what is CARLA challenge and how to create my agent. Okay, and yeah, my purpose is to be winner of this challenge in track 3, and I use auto-based approach. Yes. As a result, in evaluation of test public course, our agent achieved 5960 points. That is a difference website, difference course of this website and this test course. Yeah, this is about 50 points higher than baseline result. That is a provide of CARLA teams. That is a baseline, and this is my agent. That is a achievement results. Yes. In this presentation, I will explain this in detail. So in this challenge, CARLA team provide 4 tracks. Track 1 is user can use LiDAR and GPS and camera information. In track 2, user agent can use camera only. And track 3, user can HD maps and waypoints and all sensors. And track 4 is a different context. And I submit my agent in 3 tracks, track 1 and track 2 and track 3. And my main target is track 3. In track 1 and track 2, I use end-to-end agent, and track 3 is an auto agent. Yeah, in CARLA challenge, CARLA team evaluate our agents. That is an evaluation system. They called scenario runner. Scenario runner is developed by CARLA team. That can provide that system provide waypoints. That's a global path, and some another agent surrounding people or something, and human counts or some scenario is provided. And our agent be evaluated on these rules. Here is C is a amount of route completed. That if our car going ahead, that point raise up. And I here is interaction points. That is like if hit human, the points goes up and total score is going down. like that. This is a evaluation system, and this is an example of interactions. If ego vehicle hitting other vehicle, we get point 6 and go down total points. Yeah, like that. If pedestrian, that is a more dangerous situation, so point is high. Yeah. Like this.
This evaluation don't consider about the time, right? If you are driving really slowly, and you can get also get.
Yes, yes. Each map set deadline. So if a ego vehicle run to deadline, evaluation is stopped, and this time sequence score is used calculation.
We have a time limit.
Yeah, we have time limit. Yes. So, yeah, that's a little bit joke. I think the ideal competition in this competition is following the get started page, we can submit sample agents. Yeah, that is of course. Yeah, and the sample agent already developed, and we can just use it. And upgrade is mainly task. And in ideal competition, submission is easy. And driving system is one of battlefield. That's ideal competition. But in reality, if I follow get start page, we cannot submit, we cannot create agents. And audio agent, is developed, but implementation is not so well. And submission is one of battlefield. Yes, so maybe next year or next year challenge maybe more good this, but this challenge is first of the CARLA challenge, so maybe some problems occur. And most difficult point is a Docker maybe. They provide Docker file, but they cannot provide important information or some settings. So we try to fix this Docker file and create Docker and submit, and failure or success or sometimes. So I study about Docker file in competition, and these things I study. Yeah, if they provide correct Docker file, so contest is more high level, maybe. So, yes. Yes. In this competition, I use AutoWare agent. So, Adam already talk about this AutoWare. And in competition, they CARLA challenge teams provided baseline agent like CARLA AutoWare bridge. So if you use this, I can get this baseline agent. That is a so in this agent, we can the agent just follow a waypoint only. Object is detected but not stop. So sometimes hit object and vehicle and human. like this. So in this challenge, my task is integration. Achievement of hardware. So improvement is hardware. So yeah, I have 3 improvements. First is collision obstacle avoidance, and second is traffic light detection and recognition, and third is control function achieved. So yeah, this is a result of our agent. In this video, we can see collision avoidance like this, and obstacle avoidance. This is RDS, and this is a detected vehicle and recalculated waypoint like this.
This is a hybrid tester?
Yes.
Oh, okay.
Hybrid tester. Just yeah, hybrid tester.
Okay, I see.
And yeah, this is a traffic light detection. This is a simple deep learning algorithm, maybe SSD algorithm. Because I developed this. CARLA team provide HD maps, but this is HD maps. Maybe traffic light pose information is not included. So I need to get from image this information. So, but that is a fair case of traffic recognition. In this case, I want to get this traffic light information, but recognize the information is here. So, in this case, echo vehicle should go ahead, but this result, echo vehicle stopped. And in this scenario, this traffic light can't change. Already green and red, so echo vehicle already stopped and time limit comes. Yeah, that is a failure case. So in last submission, I cannot use traffic light recognition node. So yes.
What do you use? Okay. I think so. I think there already MXNet node in the hardware. I think, and it can detect red light and green light and other traffic light. So why don't you use this node?
Yeah, maybe I tried this node.
Yeah.
But maybe
it does not work.
Yeah,
oh.
Something wrong.
Okay.
Maybe
it needs the information from the vector map.
Oh,
so vector map is
we don't have that information.
Okay.
If we actually have vector map, we can detect like easily the traffic light.
Yeah.
Maybe
okay. I see. MXNet node detects first MXNet node extract ROI from the image using vector map and classify the I see. Okay, I see. Thank you.
Yeah. So okay. This is a baseline result in open test course. So this is a total points, 44 points, 94. And in hours, increase these points. Yeah, that's it. Good.
Failure means what?
failure case is maybe if eco vehicle departure waypoint, so the scenario is finished and this case is calculated by calculated failure. So yeah, that's that. Doesn't even failure case. So yeah, that is a visualize of the accident. The collision is decreased, but this red light is going up because the recognized node is stopped. Yeah, this is a thing. Yes, that is a finish of my presentation. Yeah, thank you. Any question?
A small question, but have you ever used the evaluation metric? Have you ever used it?
What? Have you ever?
Used the evaluation script, the evaluation, maybe this one.
This scenario runner is open source. That is provided in GitHub. So yeah, everyone use it.
Yeah, I'm just asking, have you any experience? Have you played with it? Have you used it? Because I guess you just submitted your agent and then you got the result, or you know, have you?
Automatically calculated.
Yeah, but
You don't have to include it.
I want to use this every 5 seconds and get the value out of it.
Oh.
For small rules. But in order to do that, I want to have some notifications. But I guess you never tried. You never played with it.
Actually, you can receive C and I every message, every frame. So if you receive C and I, you can calculate it yourself.
Yeah. If there is no, you can calculate it. And if you use a scenario runner, you can finally you can get the score sheet. That is a number of these infractions and timestamp, and each course score and total score you can get.
How fast was your agent driving? How fast speed?
I see. The reason of slow is control function of CARLA auto average. Maybe MPC じゃなくて
Pure parachute?
no
PC calculation.
Ackerman control, CARLA,
after that.
PID?
Yes. PID.
Yeah, we have two PIDs
Yes.
in the to convert velocity and linear velocity to acceleration and brake.
Yeah, that function is not so good. That is I stopped these modules and we just simple controller like because that is if
Accelerate and brake.
target velocity and current velocity, and if target velocity is fast, go accept and decrease is stop.
P controller.
It's P controller.
Not even PD.
Yeah.
P controller.
Simple P controller. And that is so.
But did you set maximum velocity and like to the agent?
If
Like maximum velocity of the vehicle. Like how far? Like 20 kilometer per hour, 30. Did you set maximum, or you just as fast as?
maybe not setting max.
Because for the turn,
Yeah,
what you do for the curve.
Adjustment, pure voltage.
Okay. Okay, so you get the velocity from pure pursuit, and then use the P control.
Yeah. This is simple, but better than
Of course, anything better than.
Yeah. Maybe if we choose parameter of PID controller, maybe good ego is going go well, but yeah, it is.
I did some tuning. You will find in the launch file. Yeah. By the way, I also participated. The video I was trying to show you that was working like not HD but not HD. This is the whole challenge. Locally, it works fine. I can get 100% root, and the score in the local system, I get 73%. So, like the total. But I couldn't. Every time I send the Docker file, it fails on the server.
Yeah.
So I couldn't succeed on the server.
Maybe you took it. They don't want you to submit.
Yeah, so my problem actually was in the submission. Every time I submit, I fail. But when I like run the whole scenarios, you will see 1.5 hours. It run like hit a very small number of things and finish the whole tracks. But yeah, I couldn't submit. But you will find the function and the tuning. I actually tuned the Ackermann controller, but still, if I pushed it, like make it more responsive, it is really unsmooth, like brake and accelerate fast. So we need to rewrite this part, which is we're waiting for the Ross Bridge to be rewritten. So.
So how did you create the autonomous agent? Did you base, did you use some of the baselines that they provided?
They already have the agent, designed the agent.
But did you have like an outdoor agent, but you had to design that from scratch, right? Or
no. In the challenge they have, like for CARLA AutoAir, they design one. If you are using the Python APIs, you need to create the agent from scratch. Set the sensors and the position of the sensors and everything.
So where would you say that was the main work that you had to do, like in fine-tuning the agent? Where was the main work that you say that was the hardest part?
Hard part is submission.
Yes.
Okay.
He succeeded at get scores, but I failed. So.
So you say like creating the Docker file and all those things.
Yes. I create.
And how them like you said you were gonna wait for the Ross bridge to be rewritten, but how is that related to the control part?
Because the controller, CARLA Ackermann controller is one of the Ross Bridge nodes.
It's in there, right? Okay.
So I didn't have time. I actually have idea to rewrite the two PID controllers or PD controllers. Maybe Seiya just had like simpler one to write a P controller, which is still you can tune. The controller they provide, they have two PID controllers. One PID is really difficult. Two PIDs and connected, this is really almost impossible to tune because one small change in value changes the response of the other one.
Yeah. More difficult part is make Docker file.
Oh, it's Docker file. Too long.
Yeah, crazy.
Oh, this is provided by official.
Official one.
Yeah, but you modify the
No.
official. You modify the official one.
Too long. Yeah.
You showed me the about the AI web UI, and is this an open source?
Sorry, which one?
Yeah. なんか結果が出てるみたいなところあるんですか？UI の。
どこだろう。
そう、いや、this one. Yes. While developing AD stuff, it's very important to visualize a KPI of the autonomous training. So we are finding the visualization system like this when you are. So
this is a result page. But
this page. So sort of this page is open source.
yeah, maybe. It is maybe open source.
Cool.
So the score that you showed us that you got was after it ran through here, or you ran it locally before submitting?
I create Docker and I run local and everything well. I submit this Docker file to this evaluator using this. Yeah. So after that, in evaluator server runs my agent on this environment and calculated the score and visualize leaderboard and my submission results.
Okay, so you have not used the score by yourself. You have not used the evaluation function during testing locally. Have you ever calculated the score by yourself by doing
If I use scenario runner, I calculate score in locally and same metrics calculated by server, but calculate this environment, this map or agent scenario, that is a different of local and global.
So you're saying that it's easy to play with, right? I can change, So the CNI is not a parameter, obviously, but we can.
Yes, you can. It's in the scenario, it's all Python, so I think it's
That is a submission result. You maintain fail.
still running. One submission is still running.
Yeah. It doesn't finish, maybe close. Yeah, main time failed.
Yeah, I have 22 failure. Submission failure.
If some debug page, this is the debug environment, get log of error to file, but in last in this page is we cannot get these logs, so we cannot debug.
So you don't know
Why-
what you
yeah,
failed.
Yeah.
Why do you fail?
Oh.
Why they are here?
So if it's working fine in the local system and work fine on the test submission, there is nothing else I can do. So for my agent works finish on the local and finish on the test submission and get 100% score. Because it's run with a very simple scenario, but on the actual test it fails.
Yeah.
So
So this is a local testing. So maybe Hatami already said start CARLA server. Maybe this video counts. And start lookup. I already set entry point, so low score is automatically ramped up. And evaluation script start. Yeah, that is like evaluation mode, and that is I inflection points, and that is score C. Yeah, maybe that looks
Is the agent running?
yeah, maybe service so but yeah.
So
if-
we need.
So why you didn't start? You have to set it to start, or
Oh no,
it just takes time?
just yeah.
So we need to change this function so that the competition will not take the whole route but just 5 meters. And it should do it online, so I guess there will be a lot of progress. So that hopefully not so much.
If down waypoint scores is going up, and this is a use loss bridge. So if you can show RBs and image and calculation results, you can show.
Yeah, this is a nice view from top. I always use the front camera. So I never use the top.
And this
We use
scenario,
both for visualization.
this is a vending machine.
Yes, there is
This
someone
is a
always
human.
running from.
Human go here, and yeah, that is echo beacon is so slow, but and hit this human, so this inflection points is go up.
I hit this person like 3-4 a lot.
Last thing can be said in the scenario runner, right?
It's another definition in the JSON file.
Mm, there is a lot of ways you can do programmatically, or I mean there are maybe open scenario now, so you can define position of each one, start where to start and when to
Have you
start.
tried the open scenario picture? That was
No.
recently introduced, right? In the
No,
last-
I yeah, but I didn't customize any of it. So I used only the provided scenarios for the challenge.
めっちゃうまい。
It's too much for them.
This is the recognition result of traffic light. Yeah, this is the finish of my presentation.
You went to the CVPR workshop, right?
Mhm.
Did you meet the other people
Yeah.
who also want to join? Did you get to chat with them about what they used or how they submitted?
in other participants use a ML agent, machine learning agent. So they don't use the loss, and if Docker submission difficulty is almost loss settings. So yeah, they not so not so difficult. And other participants submit conditional learning. This is a if you get this image, this thing is dangerous or not. If dangerous, they push stopped. Push brake. And if safety, they follow this waypoint. Yeah, that is one of the example of other agent. Or this is result of recognition. Yeah.
Thank you very
Thank you.
much, and congratulations.
Seiya.
Thank you.